Hey guys, here are the answers for your page 23 homework. So you can check out what you did, and then if you're struggling with any of the questions, I'm going to do the work for every single one, and that way you can pick and choose and just watch the questions that you kind of need some help with. Okay, so question number 1 is using the graph. So the question says, what is the half-life? Remember, half-life means time until you get half. So if you look at this graph, I start off with 100%. Half of 100% is 50. So the time when I have 50% is this much time. So that answer, straight off the graph, 5730 years. So then the question says, number 2, what percentage remains after one half-life? So one half-life means I take it and I divide it in half once. If I start with 100%, let's get it so we can read it, and I divide that in half, I would end up with 50%. One half-life means you only do that division once. So that's how much you have. You chop it in half. Okay, the next question is asking me how many years would it take until we get 12.5%. So let's find that place on our graph. 12.5% is here, and so if I read across, that bar happens at this amount of time, 16110 years. Now if you weren't sure of that, you could also do a quick t-chart. You could do the time and the amount of the substance. Time would start at 0. Because we're dealing in percents, remember percent means out of 100. So I could start with 100, and let's divide in half until we get that much. So we'd have 50, divide it in half again would be 25, divide it in half again, you'd have the 12.5%. And so what you could do is then, knowing the half-life from question 1, in the time column, we would add that amount. So start adding, add that half-life again, add that half-life again, and the answer comes out exactly the same as what it says on the graph. So you had 2 possible ways to get that answer. Next question, here's an amount number, and here's an amount of time. So we can set up our t-chart there. We've got time, we've got amount of substance. Remember that time always starts at 0, and we're going to add. In this one, they don't tell us the exact length of the half-life, so I just know that one half-life has gone by. And then you have to remember that we're using carbon-14, and go back to question number 1. The half-life of carbon-14 is this. So you had to pull that information from the graph and from question number 1. That's the amount that we can add. So after one half-life, 5,730 years have gone by. So if we add that again, that is the second half-life. So that means we're going to take our sample and we're going to divide it in half twice. We started with an original amount of 48 atoms. If I divide that in half once, I get 24 atoms, and again I get 12. So my final answer is I would end up with 12 atoms of that sample left. Okay, this one. Find some numbers. Here's a percentage, that's an amount, and that's all that they give us. So let's set up what we know. We know we want the time, and we know we want the amount of the substance. Okay. Remember, in the time column we're going to add, but they don't tell us the half-life. They tell us it's carbon-14. So again, you have to go to the graph, and the original half-life from 0 to 50% is 5,730 years. That is the half-life of the substance. That's the amount that we're going to add in our time column. We're always going to start at 0. If I add once, I get this, but we don't know how far we have to go. So let's see what other clues we have for the amount. They tell me that we're ending with 25%. That's what remains. Remember, percent means out of 100. So that means our starting amount was 100. If I divide that in half once, I get 50. If I divide it in half again, we get 25% that we wanted. So that means I just need to know the time that goes with that, which means we're just going to add 5730 again. That's the amount of time that we're looking for. So your answer, 10,740 years old. Alright, if I look at the next question, here's an amount of the substance, and here's a time number. Okay, so we can set up our T-chart with that. We've got the time, we've got the amount of the substance. Time always starts at 0. In this column we're going to add. Because we're still using carbon-14, we have to go back and figure out what was the half-life. So the half-life is how long does it take until you get half of that substance. And we figured that out in question number 1. This is the half-life of carbon-14 because that's how long it takes for this bar to get chopped down to 50%. So the half-life that we're going to use, half-life that we're going to add, is 5730. I'm going to add until I have this many years go by. So let's do that. Add that half-life once, add it again. Still haven't hit that goal, so we add 5,730 again. There's our goal. So now we can figure out the amount. It says we originally had 120 atoms. So we start here, and we're going to divide in half for each time that we figured out. So divide it in half once, you get 60. Divide in half again, you get 30. Divide in half one more time, you get 15. So at the end, I will have 15 atoms. Alright, these questions at the bottom use half-lives that are given in this chart right here. So you have to be careful of which substance they're talking about. So if I look in the next question, here's a number for the amount of the substance, and here's a time number. And if it's radium-226, then I'm looking for this time as my half-life. That's going to help us add in our time column. So we've got the time. We've got the amount of substance. Remember, time always starts at 0. We are going to add whatever the half-life is, and it tells us right here that our half-life is 1,600 years. Okay? So we're going to add until we get to this amount of time that they tell us. So if I add it once, I get that. If I add it again, I get that. So that was 2 half-lives that have gone by. So we're going to take our original amount that we started with 8,000 and divide it in half twice. If I divide it once, I get 4,000. If I divide it again, I get 2,000. So how much would remain is that final amount of substance, which is 2,000 atoms. Alright, let's look at the next question and get my chart. So if I look in here, here's an amount number, here's a time number, and because it says plutonium-239, if I go to my chart, this is the half-life that I'll need for that substance. Now we're ready to set up our T-chart. We've got time, we've got amount of substance, remember, time always starts at 0, and we add whatever the half-life is, which it says is this big giant number, long half-life. So I'm going to add until I get to the amount of time that they have specified. So 0 plus that number is that. Not there yet, so add that amount of time again, and then you get what they're looking for. So that means that we had 1, 2 half-lives go by. So we are going to take our original amount, which was 20 atoms, and divide it in half once, divide it in half again. At the end of this, you have 5 atoms left. Okay, if I look at this one, I want to find some numbers that will help me. Here's an amount, and here's a time. If I look at the substance I was given, it's uranium-238. Finding that in the chart, there's the half-life that we're given, so that's what we will add. So we can set up our time, we can set up our amount of the substance. Time always starts at 0, and we are going to add this big long half-life. That's what was given. So if I do that once, that's the big long number, and that's actually our goal. So what that means is this half-life has only happened once. So we can just take our original amount, which was 60, and divide it in half once. 1 half-life went by, which means that we have 30 atoms. Alright, last one. Okay, find some numbers in here to help yourself. Here's an amount number, here's a time number. It says we're looking for iodine 131, which is right here. So that's the half-life that we're going to use in our chart. So we've got time, we've got amount of substance, time always starts at 0, and we are going to add, and the half-life that we're given here is 8 days. So we're going to add 8 until we get to this time number that we were given. So 0 plus 8 is 8, plus 8 again is 16, keep going, add 8 again, you get 24, add 8 again, now we hit the 32. So that means that we had 1, 2, 3, 4 half-lives happen. So we're going to take our original amount and divide it in half 4 times. I started with 24 atoms. Divide that in half once, and you get 12. Divide in half again. Divide in half again. Divide in half again. This is the final teeny tiny amount that you will have left. Alright, let me know if you still need a little bit of help.